It's a beautiful day for math. We are entering into chapter 8, and it has to do with volume and surface area. Now, we did a lot of volume last year. Many of you were here. And volume is simply the space an object takes up. It's three-dimensional space, and it's measured in cubic units. All right, measured in cubic units. So real quick, we're going to be focusing on volume of cylinders. So a couple things you need to know. Scribble these real small up top, but we need to know the parts of a circle. So we know that from the center to the outside is called the radius. If you were to go all the way across and through the center, that's what we call the diameter. All right, and around the outside is called the circumference. We are focusing primarily with radius, but also you have to know that the radius is always half of the diameter. So if they give you a problem and they say, oh, here's the diameter, you're going to need to find the radius because our formulas all have to do with radius. All right, so take a second and pause and then try the quiz is. That should be linked into the puzzle if I figured that out. All right, and test your knowledge on circles. Good luck. All right, hopefully you did fine there. You can retake it as many times to get 100 and to really practice to nail down those basics. Here we go. So we're going to be finding volume of cylinders. We're going to be able to explain why the formula works. And when given the volume, we can find other dimensions. So you can find this last one is like working backwards. We had to find the dimensions that gave us the volume that somebody tells us. All right. Next job of yours is to pause, go to Quizzes. Nope, sorry, go to Quizlet. Go to Quizlet and find these words in the Chapter 8 vocabulary set. Find these words, copy the definitions into your notes, and then you'll be ready to figure out this formula that we're going to be using today. All right, you're back. Hopefully you copied those and you understand them a bit. Volume of cylinders formula. This is very similar to the idea of a prism. All right, so volume of prisms. Last year you learned that that was volume equals the area of the base times the height. That's what you learned last year. And what we saw was that if you could find the area of a base, let's say we have a rectangular base that's like 4 by 4. All right. If we built blocks, if we sat blocks on top of that, that'd be 4 by 4. So we could fit 16 blocks on top of that. Now, if we gave it a height that's more than just one block, all right, the idea is that if we put one layer, all right, that would be 16 blocks. If we put another layer, that'd be another 16 blocks. And if we put another layer, that'd be another 16 blocks, so on and so forth. All right, we put another layer in there, another 16 blocks. And so what we saw was that all we had to do was find what would fit on that base layer, find out how many would fit on that base layer, and then multiply it by whatever this height was. All right, so the area of the base times the height. All right, so that big B always represented the area of the base, and that was the height of the prism. All right, and the height of the prism always connected the two bases. Hopefully you remember that, right? Here's the base, here's the other base, and so the height is always what connects those two bases. So that's a quick review from last year. Now you saw that rectangular prisms, because the base was a rectangle, so volume for a rectangular prism equals, you could replace the B with length times width, and then times that by the height. So that's one of the formulas you'll need for this lesson as well, because you're going to be expected to remember that and to include that in your work as you work with cylinders too. Okay, well, look, this is very similar. All right, the cylinder idea is very similar. If we can figure out how much is on that first layer, then we can just multiply it by the height. So this is going to be B, or the area of the base, which, how do we find the area of a circle? A equals pi r squared, right? So if we find that, and then that's going to be how many layers, right? The height will tell us how many layers of that amount there'll be. You can see the layers to the left, to the right here. All right, this is the same idea. So the volume of a cylinder, we can say, is if we can find how many cubes would fit on that base and then multiply it by how many layers, we can find the volume of any cylinder. So instead of B, remember, B represents the area of the base, and the area of these circular bases can be found with pi r squared. And then we just bring that h down. So this is our formula. Yay. All right, it's just basically saying the area of the base, pi r squared, times the height of the shape. One little other piece is, even if the cylinder is sitting on its side, this is still the height. All right, and from the center of the circle out is the radius. And when you plug in for pi, we'll typically be using 3.14 as an approximation for pi. Sometimes we use 22/7, but not very often. All right, so these are just little heads up. All right, but there's our formula. That's what we're going to be using. And here it is in your notes right there. All right, this is the general formula. And when we take this and sub it in there, right? We take this. All right, if the area of the base is pi r squared, then we're going to replace the b with that, and then this is the one we're going to use. All right, so there you have it. You have a little bit of an understanding of why that equation works. All right, let's get after it. So we're going to find the volume of a cylinder, round to the nearest tenth. Those are the two things we have to be mindful of, and we're going to use our formula. Now, in this case, we don't have to use the big BH. We can just go straight to pi r squared h. All right, you have to be able to find the dimensions. In these cases, we're going to use 3.14 for pi. Substitute in 5 for the r, because we see the radius is labeled right there. And then we're going to multiply by 8.3, because that is the height. Now we're going to plug that in to our calculator and get a result. Got my calculator ready, and actually I made a little mistake. Since we're using an approximation for pi, we're not going to get an exact answer. When we type that in, we get 651.55, but we remember it says round to the nearest tenth. So our final answer is going to be 651.5. Nope. This tells you to round the 5 up to 6. So we look at our units, and we know that this is going to be cubic units, or cubes made out of, with centimeter sides. So this is called cubic centimeters. That's how many cubic centimeters would fit inside that shape. Let's go to example 2. Now, read it, think it through. There's one little problem here. It says find the volume of the cylinder. So we know that formula. We simply grab the formula and plug in numbers. But there's this little issue. Does our formula have a D in it? No. So we have to be careful whenever they give us a diameter. Careful. All right, we want to plug in the radius, and radius is half of the diameter. So remember, we're going to write the formula, pi r squared h, and we're going to say radius is half of the diameter if d equals 16, then r equals 8. All right, and that's what we're going to plug in over here. So volume equals 3.14 times 8 squared times the height here, and that tells us right there 20. All right, get your calculator. I forgot to change this to approximately because I'm not using an exact representation of pi. And I get, whoa, big number, 4,019.2 is my final answer. And I have to put my units. My units are inches. So when I calculate the volume, I get cubic inches. Not so bad so far. Why don't you guys give it a try here with these two? And then I'll put the answer in the work and you guys can check it. Good luck. Here you go. Those are the answers, and that's all the work. Check your answers. If you got them wrong, see if you can figure out where your mistake was. Where you went wrong. Fix it, learn from it, and move on. All right, we're going to pause there. That's all for today. We'll make an attempt at some more advanced cylinder problems tomorrow, and then combine those cylinders with some other shapes to do composite figures. Woo! All right, composite solids, more than one type of solid put together. We'll challenge you with that. I'm sure you're excited. Hey, that's it. Beautiful day for math. Woodworth out.